All right, so I'm back looking at another problem, in particular 1.5 in John R. Taylor's Classical Mechanics book. I know I said I was going to do these more often, but right when I said that, I got hit with a bad flu. So I'm still kind of getting better, but I'm feeling a little bit better now, and I wanted to knock a few of these out. So I figured, okay, why not? So this one says, find the angle between a body diagonal of a cube and any of its face diagonals. And then the hint says, choose a cube with side 1, so this is a unit cubed, with a corner at the origin. That's what I drew here in blue. And the opposite corner, 1, 1, 1, which is this red one. It's all the way across. That's this. Write down the vector that represents a body diagonal of another face, body diagonal, and another that represents the face diagonal, and then the angle between them as in the previous problem. And that one is this green bit. I just put it over here. Okay, so the way we're going to do this is we're going to work with our dot product, which says that I'll call the red one vector A, and I'll call the green one vector B. So vector A dotted with vector B is equal to the magnitude of A times the magnitude of B times cosine of the angle between them, which I wrote in orange. So we want to find the angle. So let's just do a little bit of algebra. The dot product divided by the magnitude of the two vectors. And then I'm going to go ahead and say cosine inverse is equal to theta. So I just divided over by the two magnitudes and then did cosine inverse. Okay, well, simple enough. All we have to do is find these numbers. So let's find A dot B first. So that's just going to be 1, I'm going to just use the same color. 1 times 1 plus 0 times 1 plus 1 times 1. So that's just 1 plus 1, which is 2. If you're not familiar with the dot product, a lot of these concepts I do explain in other videos. So I would recommend checking that out. And then the magnitude, the way we find the magnitude, we actually proved this, I think, in one of the previous problems. I don't know if it was this one or the last one. But all we have to do is take the square root of each component squared. So for example, for what we're calling vector A, it's just the square root of 1 squared plus 1 squared plus 1 squared, which is root 3. And we can do the same thing with B. And we get root 2. So cosine inverse of A dot B, which we said was just 2, all over, well, let's see, that's root 3. So root 6. Okay. And that should be equal to our theta. And if we plug that in a calculator, you will get 35.26 degrees. And that's this angle that we needed to find. So really, this is just an application of the dot product.